So the first question says, given the line of symmetry, find the other whole. So here we are given three figures, right? And we are also given the line of the symmetry. So we have to find the other whole. So how we will solve this question? It's very easy, students. You can see that this is the first hole and this is the line of symmetry here. So where will be the second hole? Obviously, it will be the mirror image of the first one. So I'll draw the second hole here, right? Similarly, if you look into the square, this is the line of symmetry here and this is the first hole. So again, the second hole will be the mirror image of it. So it will be somewhere here, right? And in the third figure, we are given a triangle with this as the line of symmetry. So this is our first hole. So second hole will be present here. Understood? Wonderful. Let's try the next question. The second question says, give an example of shape with no line of symmetry. So think about it. Can you think of such shape which has no line of symmetry? We know that in case of regular polygons, the line of symmetry is equals to their sides, right? So how will you identify such shape which is having no line of symmetry? Scalene triangle, right? Because we know that scalene triangle is not a regular polygon. All its sides are different and all its angles are also different, right? So this is one example of our shape which is having no line of symmetry. Understood? Wonderful. Let's solve the next question now. Which of the following figures have rotational symmetry of order more than 1? So students, you can see here in this figure, we are given two figures here, right? So we have to find that for which of the following the order of rotational symmetry is more than 1. So if you look here, you can see that the angle of rotation here is 120 degree, right? So we can find the order of rotational symmetry by using the formula 360 degree divided by the angle of rotation, that is 120 degree here, right? So your answer will be 3. So the order of rotational symmetry for the first figure is 3, right? Similarly, if you look into the second figure, you can find the angle of rotation as 90 degree, right? So how we will find the order of the rotational symmetry? Again, we will use the same formula, 360 degree divided by the angle of rotation 90 degree, which will give us the answer 4. That is the order of rotational symmetry here. So in both the cases, the order of rotational degree is more than 1, right? So what is our answer here? Both. Because in both the figures, we have order more than 1. Understood? Wonderful. Let's solve the next question now. So in this question, we have to find the order of the rotational symmetry for these figures. So again, if you look into the first figure, students, you can see that the angle of rotation is 90 degree. So again, using the same formula, that is 360 degree divided by 90 degree, we can calculate the order of the rotational symmetry, which is 4 for the first figure, right? Now, if you look into the second figure, which is a regular pentagon, right? So how will you find the order of rotational symmetry here? In case of regular polygons, we know that the line of symmetry is equals to the number of sides, and also the order of rotational symmetry is also equals to the number of sides, right? So the order of rotational will be 5 here, right? So this is how we will calculate the order of rotational symmetry for these figures. Understood? Great. Let's move to the next question. If a figure has 2 or more lines of symmetry, should it have rotational symmetry of order more than 1? So let us solve this question with the help of these examples. We are given two figures here. First is an equilateral triangle ABC. Okay, so it is a regular polygon, right, in which all the three sides and all the three angles are equal, right? So what is the line of symmetry here? The line of symmetry for this equilateral triangle will be 3, right? This is equals to 3. And also the order of the rotational symmetry will also be 3 here, right? Because it is a regular polygon with 3 sides, right? Now if you look into the second figure, this is a rectangle which is not a regular polygon. But if you see, students, here, the line of symmetry for this rectangle will be 2, right? And also the order of the rotational symmetry will also be 2, right? This is the center of rotation here. So that is also 2 here. Okay. Now, if you take the example of circle, so in case of circle, we can see that the line of symmetry will be infinite. And also the order of rotational symmetry will also be infinite. So what we can conclude from all these examples? That yes, if a figure has 2 or more line of symmetries, then it should have rotational symmetry of order more than 1, as you can see here, right? So the answer for the question is yes. Understood? Wonderful. Let's solve the next question now. The next question says, after rotating by 60 degrees about a center, a figure looks exactly the same as its original position. At what other angles will this happen for the figure? So we have to find the other angles. Okay, so how we will find these other angles? So obviously it will happen at the multiples of 60, right? So we can add 60. So what we will get? 120 degree. Now again adding 60 degree, what we will get? 180 degree. Then 240 degree. Then 300 and 360. Right? So these are the other angles at which the figure look exactly the same as its original position. Understood? Wonderful. So that's all from the practice session, students. Now I'll see you in the next video. Till then, keep learning, keep exploring, and spark your curiosity. Bye-bye.